All right, so now we have completed the front side of that worksheet, and now we're going to go to the back side where we continue characterizing the stream. Looks like within 5 meters of this site we have a little bit of a pool, a riffle, and a run. I'm going to estimate this at about 4 meters wide and about half a meter deep at its deepest point. The stream really isn't channelized here. There's no dam, there's no culvert. Now we want to take some measurements on the water in this stream. We're going to start with the flow rate, and to do that we have a Vernier data logger, LabQuest data logger, old school stuff, but still works. And this flow meter, it's got a little propeller that will spin once it's in the water, and how fast it's spinning is related to how quickly that water is flowing. So I'm going to take that measurement, and then while I'm in the middle of the stream, I'm going to try not to stir it up too much because we're going to be sampling invertebrates later. I'm also going to take a sample of water from the middle of the stream to do some turbidity tests and also nitrate and phosphate tests. So, here we go. Set that down for now. In the middle of the pool that I was measuring, the propeller wasn't spinning at all, so 0 meters per second for the flow rate. And I'm going to pause it while we do set up the turbidity test. All right, so here I have the turbidity meter, and this is going to read how cloudy the water is in these units called nephelometer turbidity units, or NTU. So that's what it's reading on the meter. It looks really high because there isn't a sample in there yet. So I'm going to fill this cuvette with the water that I collected in the stream, and we'll take a reading. I've got a little bit of the stream water here. I'm going to dry it off before I put it into the machine. And then the other thing we want to do is make sure there's no fingerprints on the cuvette. So if you have like a clean cloth, a clean shirt like this one, you can wipe off the outside. If you're back in the lab, you'd probably use Kim wipes or something like that to wipe it off. But I think looks like it's pretty clean and dry, and we'll get our reading here. Oh, the other thing, when you're doing this, make sure you line up the arrow on the cuvette with the arrow in the sample chamber. So he's reading, it looks like about 5.8, 8.7. Keep this out of the sun just in case that makes a difference. It does. It's about 1 point, I'm going to say 1.0 nephelometer turbidity units. So it's kind of hard to see that display, but yeah, I'm going to say, yeah, we'll say 1.0. Okay, I'm going to pause it, and then we'll go to the next test. Okay, now we're ready to test for nitrate and also nitrite, but we only need to report the nitrate. So for this we have some test strips. I'm going to use some of the water that we collected from the middle of the stream. And these are pretty easy. Just pull out a test strip and dip it in the water. Kind of run the water off the edge of the test pad, and then wait, let's see, 1 minute, and match the pad up with the color. So, dip that into the water, and run it along the edge, get the water off, and then we're going to wait 1 minute. And I'm not going to make you wait. Okay, it's been 1 minute by my watch. And here is the test pad. I think these strips are a little bit old, so I don't know if these are going to be super accurate. I'm not really seeing any pink in the test pad, but it is kind of dark. So I'll let you make up your own mind as to what you think this, what concentration of nitrite in parts per million, and what concentration of nitrate in parts per million this is. But I think this is a bad pad. I would say it's probably pretty low. Maybe, I'm going to say somewhere around 5, but feel free to make up your own mind if you have other interpretations based on this chart. All right, the next test we're going to do is phosphate, and we're going to use these test strips, but they aren't really the same kind of test strips. These are a little bit more involved. We need to get some water in this cuvette, and then it's a 2-part test pad, so you have to kind of bend them and put them into the bottle, invert it a few times, take the strip out, and then compare the color of the water to what's on the chart. So I'm going to go ahead and do that. I'm going to get 10 milliliters of water. Okay. Water. Got to strip out, and we'll try not to get these strips wet when we do that. Okay. And then bend them. Put them in the cap. That, and we're going to put that in and just invert it 5 times. Okay, and now we're going to take the cap out and take the strip out. Tool to take the strip out. You put the strip in a waste bottle so it doesn't end up contaminating the water here. And now we leave the tap off and look through the bottom of this to see which one is the closest, and hopefully I can show you without where's the camera, without spilling all the water. So actually I'm going to do this way, and you tell me which one seems the closest to the color chart. Here's the numbers on the color chart. You need those. Okay, I'm going to pause this and record what I think it is, but I'm not going to tell you. Oh, and actually one more thing about the phosphate. The water that was in here is going to go into our waste jar, and then we're going to rinse this out as well. All right, the next variable to measure is conductivity. Also sometimes called total dissolved solids, and this is essentially how salty the water is. So we're going to use the Vernier conductivity probe. This one we can put directly in the stream, but we want to make sure it's clean first. So I'm going to rinse it off into our waste bottle. Just to make sure we aren't cross-contaminating. And then I'll go ahead and put this directly in the stream, and again, try not to stir up any of the sediment. I'm going to go onto this rock here. You can almost see me. Get the probe like right out in the middle. Okay, so the reading on that was 23.2 milligrams per liter. And just for reference, like deionized water or distilled water would be 0 milligrams per liter of dissolved stuff. Okay, our next variable is going to be pH. So your pH probe comes in this electrode storage solution, which we don't want going into the stream water. So again, I'm going to rinse this off before I take the measurement. And then we can use the probe directly in the stream. So I'm going to turn the camera so you can maybe kind of see me taking that measurement. Same spot. Probe directly in the water. And it looks like we're getting a reading of 7.2. 7.20. Then we'll let it equilibrate a little bit. See if it's changing. Okay, I'm going to say 6.98 is the final reading, which is kind of unusual, a little bit alkaline, but 6.98 for the pH, and we'll go to the next measurement. All right, the next measurement we're going to do is dissolved oxygen, or sometimes just called DO for short. We will do this. Oh, here we go. What we want percent saturation. So in air, this dissolved oxygen meter is reading about 100%, maybe a little higher because it's not like saturated. Anyway, we're gonna put this in the stream, and again, we're gonna want to rinse this off before we do that. So I'll do that here real quick. And it's going to read the percentage saturation of oxygen, like compared to how much oxygen it could hold. How much oxygen does this stream have? You probably hear behind me and see behind me that little waterfall up that way. So this is this flowing water is probably going to have a fairly high percent saturation, but we'll collect the data, see what it is. Rinse it off real quick here. Make sure we aren't cross-contaminating. Okay, here we go. Again, it's going to take a little while to equilibrate. Move around. Looks like the saturation is 99%. So 99%. Is fairly well saturated. Okay, one more measurement and then we'll be done. Okay, the last measurement here is going to be temperature. So again, we're going to use the vernier probe, and again, it'll go directly in the stream, but we want to rinse it off. Before we do that, go to my printing spot here. And again, we'll need to let it equilibrate. And moving it around with that process. Looks like it's stabilized at 14.6 Celsius. So 14.6 Celsius is the temperature of this stream, and that covers kind of all the water quality variables. So the next video we'll do some macroinvertebrate sampling.